Hey guys, today I'm going to teach you how to solve two-step equations with rational numbers. By the end of this lesson, you'll be able to apply integer operation rules to solve equations with rational numbers. So go ahead and get your binder, turn to the math section. Let's go ahead and take some notes. Alright, so the first thing we can know is that equations with rational numbers can be solved just like any equation, but you have to follow the rules like we did for integer operations, and those are those adding, subtracting, multiplying, and dividing rules. Let's start with addition. If two values have the same sign, remember we need to add those values and then use the same sign. So for example, if you have $6 and you get $5, then you have $11. The same way works in reverse. If you owe $6 and you owe someone else $5, then you owe $11 in total. So remember, when you add two negatives, you're actually getting more negative. Those are the rules if the two values have the same sign, but they might be different, like in these examples. If the signs are different, that means you have a negative and a positive, then you would subtract those values and take the sign of the number with the greatest absolute value. So let's look at an example. 6 plus negative 5. Do they have the same sign? If the signs are different, we're going to subtract those numbers, 6 minus 5, like normal. That will be 1. And then we're going to take the sign of the number with the greatest value. 6 is bigger than 5, and the 6 is positive. So my answer would be positive. Here's another example. Negative 6 plus 5. The signs are different, so we're going to subtract those two values. 6 minus 5 is 1, but this time the 6 is bigger than the 5, and the 6 is negative, so the answer will stay negative. These are the rules for adding integers. So now let's look down at the practice and practice these two practice problems that involve adding these two integers. Starting with number 1. The first thing I need to decide is, are these the same sign or different signs? Since they're the same sign, I'm going to add those values and then keep that same sign. So I know 6 plus 19 is 25, and then I know my answer will be negative. Let's look at number 3. Are these two integers being added the same sign or different signs? Since they're different signs, I know I'm going to subtract those two numbers. So I know 27 minus 14 is 13. And then I know that my answer will be negative because the 27 is bigger than the 14 and the 27 is negative. I got negative 1, negative 20, and 5. Now I'm going to look down at the two practice problems that match it. I see number 2 and number 4 are subtraction problems. So let's start with number 2. Since it's a subtraction problem, I want to go ahead and rewrite the problem to add the opposite. So try that by yourself. 5 plus negative 32 is the same thing as 5 minus 32. But now that it's written like an addition problem, I can go ahead and go back to my adding integers rules. First thing I need to decide, are these two the same sign or different signs? Since they're different signs, I know that I'm going to subtract 5 from 32, and then I need to decide which one has the greatest absolute value, 5 or negative 32. Since negative 32 has the greatest absolute value and it's negative, my answer will be negative. Go ahead and try number 4 by yourself, and then press play when you're ready to check. After rewriting the problem, we should have found that negative 11 plus negative 8 equals negative 19. So far, we reviewed our adding integers rules and our subtracting integers rules. Now let's look at our multiplying and dividing rules. First things first, we're going to always just multiply and divide the two numbers like normal. Then, if the signs are the same, then the answer will be positive. So a positive times a positive is positive, just like 6 times 5 is 30. That's normal. But also, a negative times a negative will also result in a positive product. A negative times a negative is always positive. Now, if the signs are different, then your answer will be negative. So a positive times a negative is always negative. And these rules are true for multiplication and division. Just try not to get this confused with the addition and subtraction. This rule only works for multiplication and division. So let's go ahead and practice that with the last 4 problems on this page. First up is number 5. It has a negative times a negative, so I know my answer will be positive. And 8 times 9 is 72, so that's my final product. On number 6, I have a negative times a positive, so I know my answer will be negative. And then off to the side, you can do 14 times 3, which is 42. So my final product for number 6 would be negative 42. On number 7, I know that I'm looking at negative 24 and 4, but I need to remember, what does that line mean between these two numbers? You should recall that that line means divide. It's a fraction, and fractions are division. So I'm looking at negative 24 divided by 4. So I know that my answer will be negative. And then I'm thinking, what number times 4 gets me 24, which is 6. So my answer would be negative 6. Last one. The same thing. I have negative 35 divided by negative 7. It's a negative divided by a negative, so I know my answer will be positive. And then it's 35 divided by 7, which is 5. And that's it for our integer operations review. Using these rules for positive and negative integers is going to be really useful when we start solving these two-step equations. So here's our first example of that now. We're going to practice solving these equations below. I'm going to go ahead and do number 9 for you, so watch and pay attention. I see an equation with the variable k. I know that my goal with an equation is to try to figure out what that missing number is. So I go ahead and draw a line on my equals, and I'm going to try to get my k on one side and all my numbers on the other side. I'm going to do this by undoing my operation. So I'm going in reverse. So since I see a plus 9, I want to go ahead and get rid of that first. I get rid of a plus 9 with a minus 9. And if I do it to one side, I have to do it to the other side. Then I can go ahead and simplify. 9 and negative 9 cancel, and I can do 32 minus 9, which is 23. Now I'm looking at a negative 4 right next to that variable. I got to remember, what does it mean when a number and a letter are right next to each other like that? It means multiplication. So I know that since this is times negative 4, I need to go ahead and divide by negative 4. And if I do it to one side, I have to do it to the other side. Now I'm going to go ahead and simplify 23 divided by negative 4. It's a positive divided by a negative, so I know my answer will be negative. And I'm going to try to figure out how many times 4 can go into 23. So 4 goes in 4, 8, 12, 16, 20. That's 5 whole times with 3 left over out of that 4. So negative 5 3/4. To check this, I'm going to go ahead and plug in what I got for k back into the original equation. When I do that, I end up with 32. Since that's what the original equation equaled, I know I did my math correctly. Question 11 is a problem very similar to the one I just showed you, so let's go through this together. The first thing I want to do when I look at this equation is draw my line down that equals, because my equation must be balanced. My goal when I solve this equation is to get that x all by itself on one side, and I want all my numbers on the other. So I'm going to go in reverse PEMDAS to solve these, so I'm going to get rid of any addition first. So the first thing I need to get rid of is the plus 8. I get rid of a plus 8 by doing minus 8. And if I do it to one side, I have to do it to the other side. 8 and negative 8 cancel out. The other side, I have negative 10 plus negative 8. Without using a calculator, what is negative 10 plus negative 8? You should get negative 18. Now I have 3x equals negative 18. What operation is it when you have that number next to that variable? It's being multiplied, so you're going to get rid of it with division. So you're going to do it to both sides. 3 divided by 3 is 1, so you're left with 1x equals a negative divided by a positive. That means that my answer will be negative, and 18 divided by 3 is 6. So negative 6 is what x equals. At this point, how can I check to see that I did my math correctly? You should plug it back into the original equation. When you get that done, it gets negative 10 equals negative 10, which means you did it correctly. Let's go ahead and try number 12 all by yourself, and then press play whenever you're ready to check. You should have ended up with x equals negative 12.5, and then remember, you can always plug that back in to the original equation to check. At this point, I'm going to go ahead and work out number 15 wrong. So this is where Billy Bob is taking over, and I'm going to do every step of this wrong. Your job is to point out my mistake at every step. So I'll go ahead and start by drawing my line. Absolutely, that line needs to be drawn down the equals. Now we want to get rid of our addition and subtraction. So I'm going to go ahead and get rid of that plus 7 with the plus 7. And I'm going to do it to both sides. Yeah, we don't get rid of a plus 7 with a plus 7. We need to get rid of it with a minus 7. When we do that, we go ahead and cancel it out here, and we go ahead and do negative 32 minus 7. When I do that, I'm left with negative 2x equals negative 25. That might have been a hard one to spot, but if you have a negative 32 and you're going down 7 more, you're getting more negative. So it should be negative 39. Now I'm going to go ahead and I'm going to add 2 to both sides to get rid of that negative 2. That will be a mistake because we don't get rid of a times negative 2 with addition. We need to get rid of a times with a division. After dividing these two numbers, I'm left with negative 19.5. Hopefully you caught that. It should be just positive 19.5 or 19.5. Now I'm going to go ahead and look at another example for you. Number 10 is very similar to the other questions that we did with just a slight difference. There's a division and a subtraction. But just like before, I'm going to get rid of any addition or subtraction first. So I'm going to get rid of that minus 14 with a plus 14. And if I do it to one side, I have to do it to the other side. I'm left with x over 2 equals 34. Now I need to get rid of that divide by 2. The way to get rid of a divide is to multiply. So I'm going to multiply both sides by 2. So I'm left with x equals 68. I want to go ahead and check my answer. When I plug in 68 for the x, I do 68 divided by 2, then take away 14, and that equals 20. Since 20 equals 20, I know I did my math correctly. 13 looks very similar to that one, so we're going to walk through this one together. The very first step that I do is draw my line down the equals. Then I want to get rid of any addition or subtraction first. Since I want to get rid of that plus 7, I'm going to go ahead and minus 7. And if I do it to one side, I have to do it to the other side. 7 and negative 7 cancel. Now I'm looking at negative 11 minus 7. That is negative 18. And on the other side, I'm left with the x over 6. Now I see that line. Now I know it means to divide. So I'm getting rid of the divide by 6 by multiplying by 6. And if I do it to one side, I have to do it to the other side. So I'm left with 1x, and I have a negative times a positive. I know that's going to be negative, and it's 18 times 6, so I can go ahead and do that off to the side. I got 108, and my answer was negative, so my final answer would be negative 108. And I want to go ahead and plug that in to check. Since it comes out to be negative 11, I know I did my math correctly. 14 is almost the exact same, so go ahead and try that one all by yourself, and then press play when you're ready to check. Hopefully you at least got to this point. If you're stuck here, I just want to remind you that that's a divide by negative 3, so we need to do the opposite of divide, which is to multiply. And when we do that, we end up with x equals negative 30. You can plug that answer back in to check. All right, at this point, we've looked at 3 example problems with a division and then an addition or subtraction. So now I'm going to go ahead and do number 16, and I'm going to do this incorrectly. Your job is to figure out my mistake at every step. Okay, so the first step I'm going to do is draw my line. Not down the subtraction sign, I draw my line down the equals. The equal sign separates my equation. Now I'm going to go ahead and get rid of the negative 15 by subtracting 15. I'm going to do it to both sides. Should be addition to get rid of the minus 15. And when I do that, I know that this side's going to cancel out and the other side leaves me with negative 45. That answer should be negative because there's more negatives than positives. However, if the signs are different, I'm going to subtract them. 35 minus 15 is 20. So negative 20 equals x over negative 2. I know that that line means to subtract, so I'm going to go ahead and add 2 to both sides. Good. Hopefully you realize that the line means divide, and the opposite of division is multiplication. So I'm going to multiply negative 2 by both sides. That leaves me with 1x equals a negative times a negative, which is still negative. Hopefully you caught that. That is incorrect. A negative times negative is positive, and then 20 times 2 is 40. That's it. I can plug in 40 into my original equation to check my answer. All right, so last question. It says Margot solves several equations and then states that all of them have a solution of x equals 7. However, Kenneth disagrees. Determine which of the following equations have a solution of x equals 7, and then justify your response. All right, guys, that's it. If you made it to the end of this video, what I want you to do is describe a time whenever you're really proud of yourself. Today, we learned all about solving two-step equations with rational numbers. So now you should be able to apply those integer operation strategies to solve those equations. Now, what I want you to do is go back to the calendar and click any other assignments you have left for the day. Let me know if you have any questions. Bye!